Hello everyone, myself Shivangi Patel. I am from 4th year BPT. Today I am going to talk about a very important concept in biostatistics, that is correction factor, inclusive and exclusive data, and how to convert inclusive data into the exclusive data. These are the fundamental when we deal with grouped frequency data in the statistics. So first of all, what is correction factor? So a correction factor is used when we convert inclusive class intervals to exclusive class intervals. In inclusive data, the class intervals include both lower and upper boundaries. But in exclusive data, the upper limit of one class is equal to the lower limit of the next class. The correction factor is calculated by correction factor is equal to lower limit of next class is subtracted by the upper limit of current class divided by 2. It helps us to adjust the class boundaries so that the intervals do not overlap. Now, coming towards the inclusive data. So, inclusive data means that both the lower and upper limits of class intervals are included in that class. Example, 10 to 19, 20 to 29, 30 to 39. Here a value of 19 belongs to the first class and 20 belongs to the second. Inclusive data is usually used in discrete data such as number of children, number of visits to a clinic, etc. Now coming towards the exclusive data. So exclusive data means the upper limit is not included in the class. It is a part of the next class. Like example, 10 to 20, 20 to 30, 30 to 40. In this case, a value of 20 belongs to the second class, not the first. So exclusive data is typically used for continuous data such as height, weight, blood pressure, etc. Now, how to convert inclusive data into the exclusive data? So, to convert inclusive data into exclusive form, we used a correction factor. As I mentioned earlier, here's how. We will see step by step. First, find the difference between the lower limit of the next class and the upper limit of the current class. Second, divide it by 2 is your correction factor. Now, subtract the correction factor from the lower limit. Then we have to add the correction factor to the upper limit. Now let's see the example. So inclusive class 10 to 19, 20 to 29, correction factor is 20 minus 19 divided by 2, that is our 0.5. Now convert. First class becomes 9.5 to 19.5, second class becomes 19.5 to 29.5. Now it is in exclusive form. So conclusion for this is, in inclusive data includes both boundaries and exclusive data excludes the upper boundary. We use a correction factor to convert inclusive to exclusive data for accurate analysis, especially when dealing with the continuous variables in biostatistics. Understanding this concept helps ensure that we analyze and interpret data correctly, especially in health related research and surveys. Thank you.